7.
I was going to ask you.
So in 7, they tell you that you have the centroid. And centroid is the segment in which, or that's not segment, the point at which all of your medians intersect one another. So we know that you've got the 2/3, 1/3 stuff going on. If we know that this is the centroid, they tell you that CM is 36, MQ is 30, and TS, the whole thing, is 56. Now, it's only asking you to figure out what AM is. Well, AM is the portion from vertex to centroid, and we know the centroid to side is 30. So if centroid to side is 30, what do you do to that to make the other part? You double it. Very good. So it is 60. What they did here is they gave you more information than what you needed to do to annoy you. Because you had the 36, which means you would have had an 18. You had a 56, which means you would have had 2/3, 1/3, and all that other stuff. So, okay. What else we got? Anything? Yes, sir. 35. I hate scrolling in this thing. Once again, I hope that you guys found that by. Anyway, so 35 deals with segment AD and DE. Now, I hope that you guys did this where you drew the segment outside of the triangle, where you had your vertex, centroid, and side. We know that we have AD is vertex to centroid. We have DE, which is centroid to side. Now I left up the 5 possible ways of being able to write this stuff out. Which one of them deals with just vertex to centroid and centroid to side? There's 2 of them. One of them is just easier to use than the other. Yes, sir? The doubling, yeah, exactly. Now there's nothing wrong with using the half version of it, but if we don't worry about the half version, we don't have to worry about fractional amounts. So if I always skip down, whenever I have just vertex to centroid or centroid to side, I'm going to use this version. Because if I double the smaller segment, the centroid to side, it will always equal the longer segment, the vertex to centroid. So I write it out. If I double my centroid to side, it will equal my vertex to centroid. So centroid to side is DE, 3x minus 2. That has to equal 5x. From there, it's really fast. We get 6x minus 4 is 5x. Move 4, move 5x, so you get x is. Very good.
Here you go.
Gee, thanks.
It's on the Catherine.
Well, I think she's turning it in.
You know, if you just walked around smiling all the time, your life would be better.
It would be, Brian.
Nigel?
Riley.
I told you that.
Hey, only I can harass her.
Nobody.
Make sure your name's right and set it up. So, you guys have actually done this before. You've done a little bit of this before. For example, if I say that I have angle A is 42 degrees, angle B is 100, and angle C is 38 degrees. Excuse me. Which one of those angles is the largest?
Angle B.
Angle B. And why is angle B the largest?
The biggest number.
It's the biggest number. Pretty simple, isn't it? So if I put these in order from largest to smallest, it would go angle B, angle A, and then angle C.
Smallest to largest?
I said largest to smallest. If I put it smallest to largest, it would just be the opposite order.
Yeah, I thought you said that.
That's right. Now, and I'm glad you asked that because sometimes it will say put them in order from smallest to largest, sometimes it'll say largest to smallest. So, reading. Now, the next part of this is, if I draw the triangle, how many angles does a triangle have? 3 of them. Does it matter if it's exact? No. Does it matter where I start my letters? Does it really? No. I mean, you think about it. Because if I put angle B here, and then A here, and C here, if I flip-flopped A and C, it would just be going the other direction. It's still going to be angle B. And that's what's cool about triangles. Generally speaking, the placement of the letters doesn't really matter. Okay? Now, if I go through and I fill in the blanks here, I know that this is 100, this is 42, and this is 38. Which one of those sides do you think is probably the longest? That's an angle. B is an angle. Which one of those sides do you think is the longest? You're saying AB. AC. Here's why. It's going to be... the side longest is always going to be across from the largest angle. Now what I want you to do is think about what we did the other day with right triangles. In a triangle, can you have more than one right angle? No. So no matter what, in a right angle, this is always going to be the largest angle. What side length is always opposite a right angle? A hypotenuse. A hypotenuse is always the longest side length. Now the other two were called legs, but we knew that largest angle was always across from the longest side, the largest side. So what happens here is you get the same idea. The largest angle is always across from the longest side. Where do you think the medium angle is going to be across from? The medium side. Whew, this last one's going to be tough. I have a feeling you can probably figure it out. Where do you think the small angle is going to be across from? The small side. Very good. Now I'm going to throw a wrench in this here. What happens if you have sides that are the same? No. And the angles are equal. Very good. Think about that. If you have an isosceles triangle, you've got two base angles that are the same, correct? If the two base angles are the same, they're always looking at the two sides that are the same. So if your two angles happen to be the same measurement, they're always going to be across from the same side lengths because those will have the same measurement. Also goes to play with the idea of all three angles being the same side. Because if you have all three of the same side, what do you know about all three angles then? They're also the same. That's why all of that worked. Okay? So this is what we call that triangle inequality, where small angles across from the small side, big angles across from the big angle, and the mediums across from the medium. Okay? Like I said, that was probably the most difficult thing we've done all year. You're okay with that? Okay. Now, let's take it a step further. What happens if I give you side lengths? Let's say I give you 3 side lengths, and I ask if we can make a triangle out of it. I'm doing an example here of one that we know that works because we talked about what we called a 3, 4, 5 triangle, a triple for a right triangle just the other day. Remember 3 squared plus 4 squared equal 5 squared? I'm going to use this example because we know it creates a triangle. And let me show you why it does. Do you guys remember how to work with inequalities? Greater than, less than, that kind of stuff? So what we do here is that since there are 3 sides, there are 3 different inequalities that always hold true if you can make a triangle. Watch what happens. 3 plus 4, is it bigger than 5? Is 4 plus 5 bigger than 3? Is 5 plus 3 bigger than 4? Yeah. Do you see how I just rotated the numbers? I started with 3, 4, 5, then I put the 3 at the end, moved everything up, then I put the 5 at the 4 at the end and moved everything up. I just rewrote them 3 times. Those are the 3 possible ways of writing out the inequalities. Are those all true? Yeah, 7's bigger than 5. Yay. 9 is bigger than 3. Yay. And 8 is bigger than 4. Yay. That's why you can make a triangle out of it. Watch what happens if it doesn't. One, 3, and 6.
No.
When I start this out, 1 plus 3, is that bigger than 6? Is 3 plus 6 bigger than 1? Is 6 plus 1 bigger than 3? Well, is 1 plus 3 bigger than 6?
Obviously.
No. So does that mean I can make a triangle even though these are happy? No. I cannot make a triangle. What this right here is, remember when we talked about what's called a counterexample? A counterexample is anything that negates a theorem, an idea, a hypothesis. My hypothesis here was that I can make a triangle out of side lengths of 1, 3, and 6. I just showed that I can't if I combine them back and do it that way. Okay? That's all this means. I know that was a lot. Are you going to be okay if I do one more thing with this? Okay? Remember, if only one of them doesn't work, it automatically, you can't make a triangle. Even though the other 2 work, one doesn't work, it's a complete failure. Sounds harsh, but true. Okay? Now, what happens then if I just give you side lengths of, and I ask, what are all of the other possible side lengths that you need, that you could make a triangle out of? What are the other side lengths that x could be to make a triangle? What's the, I should say this, what's the range? What values would make this a true statement? Which means that x could be a bunch of different numbers. What we're going to do is figure out how to do that. And guess what? You do it the same way. You write out 3 inequalities just by rotating through like we did the second one. I write out 11 plus 4 is bigger than x. 4 plus x is bigger than 11. X plus 11 is bigger than 4. Everybody see how I'm just rotating through the numbers, just bringing them around? Just do it that way. You'll be very hard pressed to screw it up. Yes, ma'am?
We don't need negative numbers.
I see where you're seeing that right now. Can you have negative side length? No. Now, here's what happens when I talk about the range here. What's 11 plus 4? 15. So this says that if you read this backwards, x is smaller than 15. Or 15 is bigger than x. Everybody okay with that? Here, I move it around, I get x is bigger than 7, just by subtracting. Here, this is where you're saying you have x has to be greater than negative, what is that, negative 7. Can I have a segment length that's negative then? No. So what we do, yes sir?
Should the little arrow thing be facing the other way?
I'm going to show you what I do here in a second.
Okay.
Okay. When I get to this point here, you're right. You're always going to have one of them that could wind up being negative, or it could wind up being 0. I know that this won't work because I can't say that I have a side length of negative 6. But that I can say x is always can be between, what's the small number? Which one's smaller? Which one's bigger? x is between 7 and 15. I think this is where you're going. When we write these out, we always would say that these two have to be greater than the third, these two are bigger than the third, and so on. But
Well,
when
I
you,
just mean like that, what I learned is those things are like alligators and they
Yeah.
want to eat the smaller number. not
no, they always eat the bigger number. Alligators want to eat more people.
I thought it was the small.
Oh.
Then never mind.
Yeah, think Pac-Man.
Oh, yeah. Told you, B.
What's that?
No.
So when you go to do this, what happens here is that anytime you have this value where you wind up with numbers of, I don't know, 8, 13, and something, you write out your inequalities. And like you were saying, is that one of these could always wind up with either a 0 value or a negative value. So you immediately discard it. And your answers are always going to be between, x is going to be between two things. So it always, your inequalities will always be like that. Well, what's 8 and 13? And what's the 13 minus 8? You see what I'm doing? I'm adding them and I'm subtracting. I add them and it goes here. I subtract them and it goes here. 11 and 4. I add them, it goes here. I subtract them, it goes here. That's all you do. You add them, you subtract them, and it works every time. It's a nice shortcut. So like I said, this is probably the easiest day of math we've had in a long, long time.
You're gonna touch tomorrow.
Yeah.
It'll just go through the section one.
5 will be incorporated in it, but it'll have everything else too. Okay. So, yeah. So, like I'm saying,
It'll be like no proof stuff.
no proof stuff. What we had here is we had 4 sections. We basically have 5 sections. Mid-segment. So what we basically have done is worked really in 4 sections, and then today I just kind of said, hey, add them, subtract them. So you got that, the easy stuff. Now, when you go back and think about what we had, you had mid-segments. Mid-segments were the segment that connected what in the triangles? The what? The midpoints. Mid-segments connect midpoints. That's pretty easy. Perpendicular bisectors were the ones that you drew from an angle to the perpendicular bisector of the side. It had a special point to it. It had that thing called the circumcenter. The circumcenter was that point that showed it was point to vertex was congruent. The angle bisectors had the other one, the incenter. That was the one that was point to side. And then the last one that we did yesterday was the medians. And I left up the fun median stuff up there. That was the centroid. And then today, obviously, is the easy stuff of the triangle inequality. Now, like I said, since honestly we could probably have stretched this through and done it a 2 more days of this, but there's no reason to waste our time. There's no reason. So
No more passes.
We'll figure something out. It's just really gross that people touch that. Yeah. The- Still kind of gross.
Just
Touch
hold
that.
punch it again in a minute.
Yeah.
You doesn't want to touch it.
I'm not touching that thing. No way. Yeah.
Just grab the whole puncher and just.
Yeah, pretty much. Just get a staple gun. Just do that. So what I'm getting at here is, I think that it's a pretty easy break point here on this because could we get a little bit more in depth with some of the inequality stuff? Yeah, but do we need it for anything? No. Does it come up again next year or later in the semester or even next year? No.
Or later in life.
No. It really doesn't. Honestly, the big thing in this stuff that will come back up and around is that big angle, small angle stuff. That does show up again next semester. We do a little bit of like the law of sines and things like that when we talk about where angles are placed within a triangle when we try to solve for the side lengths. Because eventually, you know that triangle we drew up there a second ago?
Yes.
Where we had the 100, the 42, and the 38, where this was B, A, and C. Next semester, we'll call this side little b, little a, and little c, and we'll actually be able to figure out the lengths of those sides given the angle measurements. And there's a reason, there's a specific order in which you have to do things by solving for the largest side first. Yeah, you would solve for side B first. Okay. So that does come back up. Inequality, not really. But the other stuff, that's why I wanted to make sure, I wanted to show you guys where I put another tab into, or another link on the website itself. So if you have your Chromebook, pop that open real quick. I want to show you where I placed this thing real fast so you can find it.
When are you gonna get your kids for Christmas?
We actually have already gotten most of the stuff. If I had leftover, I bought a bunch of stuff last year when it was on sale.
Nice.
Really?
Oh yeah. Preemptive purchases are the way to go.
Where'd you get them?
Can't say.
Oh yeah, well I tell them. Yep, and then I have
All right.
a Christmas ornament.
Excuse me. So, hey, what chapter are we in? All right, so let's see. So I should probably select chapter 5. You think? I'm gonna assume that you could probably figure that out.
Click me for the extra practice problem.
Hey, look at that! Kevin found it. It says, "Click me for the extra practice problems" in the back of the book. So what do you think I'm going to tell you to click on?
Me.
Click on the extra practice problems at the back of the book.
So if you click that, it'll open up the PDF file. Now, in the back of the textbooks, there's always these extra resources. You'll have, answers for the odd numbers. You'll have all that other stuff in there. But if you scroll through here, what the geometry book has done, which is pretty nice, you have to go for a while. Anyway, so if I scroll through, it starts going chapter by chapter with extra practice problems. Convenient that it's called that. And you'll see that you'll have, eventually at chapter 5, I believe it starts on page 904 if you're looking at the lower corners. You've got all these different sections with different parts to them. Now, what I've assigned, it's already on the calendar for you guys. It's already on the calendar, and there's a link to the PDF with all of it on there. I have certain numbers in here that I want you guys to do. I think it's, 1 through 5, and then 10 through 17, 10 through 27, which is, as you can see, all these things are ridiculously fast algebra problems. And then you get to the back side here, you have a centroid problem here. And then it talks about listing. Now, Nigel, this is what you're saying about smallest to largest. These questions here ask you to put the angles in smallest to largest. So if I'm looking at 34, I've got side lengths of 7, 11, and 14. Which one is longer? Or I'm sorry, which one's the smallest one? 7, which means what angle is across from 7? R. So it would go R, Q, and then P. Okay? And then I have a couple of these here where they're just find the third side. Okay? Yes, sir.
Will this stuff be up over winter break?
What's that?
Will this stuff be up over winter break?
Oh yeah. This stuff. Getting there. What I plan on doing over the course, because we're going to be able to start and get through most of 6 before break, which is kind of what I want to be able to do. And
Oh, thanks for the notes.
yeah, and that's the other thing. I figured why stretch it through? Then I give you guys a note card and put the onus on you guys to study a little bit extra for it. But it gives me a little bit of time and a little bit of breather room for chapter 6. Chapter 6 isn't very long, but if you start thinking about how many days we have left, if you start going by the days we have left, we have next week we've got what? Monday, Tuesday, Wednesday, Thursday, Friday. Monday, Tuesday, Wednesday, Thursday, Friday. Monday, Tuesday. Next week I'm out Tuesday for the math team competition. Next Thursday we only have a half day.
Can I join the math team?
No. So here you're going to be working 6-1 for a couple of days. Here we'll be in 6-2, obviously for the half day. Then we go 6-3, 6-4, 6-5, 6-6. A little bit of review. I think one of these we have to do as after the second day, but I'm looking at probably having to test here. I don't want to do it on a Monday, but I kind of think we kind of have to. That way there's the buffer of I'm sick on Tuesday and I don't come after, to go extend our break type of thing. Or if you're sick on Monday, you're here on Tuesday or
I
something
always
like
get
those.
sick on the last day.
Well, it's a good thing because then I would probably have to test on that Monday. So I know we haven't done anything with a Monday assessment, quizzes, or tests, but it does happen from time to time. This might be the only time it happens. Okay? But it kind of gives us a little bit of a buffer to work through it. Yes, sir.
What problem?
Oh, sorry. The problems I want you guys to do, I have it on the calendar, I thought. So it's the extra practice. It's on page 904. I think it says 1 through.
Page 904. Lordy.
You can do Control F and then just.
Wait a second. Oh.
1 through 5. All right, I would have you guys do those. I'll collect that tomorrow. Make sure you write that down about the centroid stuff before you walk out of here, because that's got all the information you need. The other stuff was the easy stuff. You have all the other information about the other segments in your notes. Okay. If you go back to this, I'll split the page. You can write them both down. If you come back to what I have here on the left-hand side of the screen, that's the information of the problems, or of the types of problems that we've done. Making sure you know what do the perpendicular bisectors run into. What is that name of the segment? What is the name, or not segment, what is the name of the point that they run into? What is the name of the point that the angle bisectors run into? What is the name of the point that the medians run into? And so on. Where is it equal? Is it point to side? Is it vertex to angle? Things like that. So that's the stuff you want to make sure that you have written down as you're going through. Think about the diagrams that we created in class. Think about the ways we wrote them. Yes, sir.
You should know that.
Try that.
It's optional.
Stand up so you can actually see what's on it. First, accept omitting any problems. Espanol, dos, el blacos, or what we say?
I know you told us.
Yeah.
So should I join?
Join it.
Okay, maybe. I'm not saying.
What's going on? I was helping him tie a tie.
I said hi.
I said, come on.
No, he's learning. It takes time. You don't wear ties very often. You don't know.
Bye, friend.
Adios. Oh, he's.
What's your favorite holiday?
I like Christmas. Yes, sir.